Hey everyone, if you're sitting the IGCSE Physics soon, today's video is perfect practice. We're solving paper 1 from the May 2025 series. So let's get started. Let's jump right into the first question of this paper. The diagram shows a measuring cylinder containing liquid. What is the volume of liquid in the measuring cylinder? Let's zoom into this figure to see cleanly what's going on. Here we see that to go from 10 centimeter cube to 20 centimeter cube, how many markings do we have? 1, 2, 3, 4, and 5. So 5 markings on the cylinder correspond to 10 centimeter cube. This means one marking must give us 2 centimeter cube increase in volume. How many markings do we have to reach this spot? Well, we need to have 1, 2, 3 markings. That means 3 markings would be an increase in 6 centimeter cube of volume. We already had 10 centimeter cube and we add 6 to that. That gives us 16 centimeter cube of volume. So the answer is 16 centimeter cube. Now let's look at the second question. Which statement about the speed and velocity of an object is correct? Option A, the speed and velocity of an object are always greater than 0. Now that is not true. The velocity of an object can be negative. If we choose the right side to be the positive direction of velocity and an object moves leftwards, its velocity would be negative, and that's less than 0. So option A is not true. Option B says the speed of an object is always greater than its velocity. Now that's not always true. Sometimes the speed and velocity could be equal and same. Now let's take an example. Suppose we have an object that is moving to the right and this direction is positive. So if it's moving with a speed of 2 meters per second, it's the same thing as saying its velocity is 2 meters per second. In this case, the speed and velocity are equal. If the object were going leftwards, its velocity would be minus 2 meters per second and its speed would be 2 meters per second. In this case, the velocity and speed are different. So option B is not correct. Option C says the velocity of an object is equal to its speed in a given direction. Now that's exactly what we discussed here. If an object is moving to the right with a speed of 2 meters per second, that's the same thing as its velocity. Its velocity is positive 2 meters per second. So this means option C is correct. Let's also have a look at option D. Speed can be measured in meters per second, which is true, but velocity can only be measured in kilometers per hour. No, that's false. Speed and velocity can both be measured in meters per second and kilometers per hour. Alright, so we're done with question 2. Let's move on to the third question. The table shows a student's time in 3 races. Race 1, it moves a distance of 100 meters in 12 seconds. In the second race, it moves 150 meters in 17 seconds. And in the third race, it moves 200 meters in 25 seconds. The question is, what is the order of the students' average speeds in each race, from lowest to highest? So the lowest average speed will be ranked first, followed by faster and faster speeds. Alright, let's find the speed in the first race, the average speed. How do we do that? Well, average speed, I'll call that V1. Speed in the first race is distance divided by time. I can do the same in the second race. The average speed in the second race is distance divided by time. Same story for the third race. which is 200 meters divided by 25 seconds. Now I can quickly do 200 divided by 25, and that would be 8 meters per second. That's the speed in the third race. I can also make a quick estimate of 100 divided by 12. This is almost 8 point something. I don't know the other digits, but it is greater than 8. Now if we look at the options, we must see that V1 is a faster speed than V3. So the third race should occur first in the ranking order. The only option that does that is option D. It's only in option D that the speed 3 is ranked before speed 1. So we didn't even have to calculate this. We just saved a couple of seconds by doing this trick. Great. Let's move on to the next problem. The fourth problem says which row gives the correct weight for the mass shown when it is at the Earth's surface. Now the first option is mass of 2 kilograms with a weight of 19.6 newtons. Now you should remember the equation we have is weight of an object equals mass of that object times the acceleration due to gravity, which has a value of 9.8. In our case, the mass is 2 kilograms and we'll multiply it with 9.8, which turns out to be 19.6 newtons. So option A is correct. We don't need to go through all of them. Let's move on to question 5. The masses and volumes of 4 objects are shown. Which object floats in a liquid of density 1.4 grams per centimeter cube? Alright, let's try and figure out the density in case A. Density is simply given as mass of the object divided by volume of the object. In the first case, the mass is 1 gram. We divide it by 0.5, which will be 2. Now the density of the object is greater than the fluid's density. So mass A is going to sink. Let's repeat the same process for mass B. The mass is 2 grams and we divide it by 3, which is 0.6 something. Now 0.6 is smaller than 1.4. Therefore, this object is going to float. So the correct option is option B. Let's move on to question 6. Question 6 says a car is driven from rest on a long straight road. The car engine exerts a constant driving force. The diagram shows the horizontal forces acting on the car. The resistive forces are proportional to the speed of the car. So the forces acting on our car are the force from the engine pushing it forwards and the resistive forces trying to stop it. Why does the car eventually reach a maximum speed? Now you see, if the car reaches a maximum speed, that means it neither gets faster and neither gets slower. It's coasting at that maximum speed. Why does that happen? Let's look at option A. The resistive forces decrease to make the acceleration of the car negative. Is that true? Well, not quite. When the car starts from rest and the engine is pushing the car, the speed of the car increases. If the speed of the car increases, what happens to the resistive forces? The resistive forces increase. How do I know that? Well, that's what the question says. The resistive forces are proportional to the speed of the car. More speed, more resistive force. So option A is not true. It's incorrect. The resistive forces increase as the car moves forward. In the same way, option B is also not true. It says the resistive forces decrease. What about option C? The resistive forces increase to make the acceleration of the car negative. Well, this portion is correct. The resistive forces increase. But do they make the acceleration of the car negative when it's moving at its maximum speed? No. The acceleration must be zero. When the car is moving at its maximum speed, it's neither speeding up nor is it slowing down. If the speed is constant, the acceleration must be zero. Alright, that means option C is not correct. It's option D which is correct. The resistive forces increase and, and finally they make the acceleration of the car zero. When the acceleration is zero, the car moves at a constant speed. So that solves problem 6. Let's move on to the next one. A mattress placed on a bed contains many compression springs. They're shown here. Which energy store of the mattress increases when a person lies on the bed? When a person lies on the bed, what happens to the springs? They get squished, they get compressed. Now that's elastic potential energy. And we can quickly see that is an option given here. Let's move on to question 8. Which energy resource does not contain a store of chemical energy? Biofuel? Well, biofuel does contain chemical energy. When we try and use a biofuel, there's a chemical reaction that happens. And that chemical reaction releases chemical energy. Same story with coal. But what about nuclear fuel? If we have a nuclear fuel such as uranium, it's the nucleus that breaks down due to fission or two nuclei combined together in fusion that gives us energy. So it's not chemical energy in a nuclear fuel. In nuclear fuel, the fuel comes from the nuclear energy itself. So option C is the correct option. Let's try question 9. A person carries 20 tiles from the ground to the roof of a house. Each tile has a mass of 1.2 kilograms. The roof of the house is 15 meters above the ground. How much work does the person do against gravity on the tiles in carrying them to the roof? A quick sketch might be helpful. Let's say this is our house and these are the tiles lying around and this height is 15 meters. Now, how much work does the person do? Whatever work the person does in pushing the tiles gets stored as gravitational potential energy, for which we do have a formula. What's the formula for that? Well, the formula is mgh, where m is the total mass of the tiles. G is 9.8, H is 15. So let's plug in the values. The total mass would be mass of each tile times the number of tiles, that's m. G is 9.8 and H is 15. Alright, I can see that this calculation is messy, so I'm going to make a quick approximation to save time. I just substituted 10 instead of 9.8. I did that to make a quick estimation of the value. I'm going to multiply 20 and 15 together and 1.2 and 10 together. I think that's the best way. So that gives me 20 times 300, which is 3600 joules. Now our estimate is going to be a tad bit larger than the actual value, but we can clearly see that the correct answer should be 3500 joules. Now that solves our problem. Let's move on to question 10. Which pair of changes applied at the same time always increases the pressure that a brick exerts on the ground? So we have to look at a particular combination that increases the pressure that the brick presses down on the ground. We know that the equation for pressure is force over area. Alright. Now if you look at option A, if we increase the weight of the brick, the force increases. But if you increase the area with the ground, the pressure decreases. So option A is not correct. Option B, you increase the weight, which is good, and you decrease the area. So you decrease A. That also leads to an increase in pressure. So it's option B that is correct. I hope you found this video helpful. I'll see you in the next video with 10 more problems. I also tutor physics, so if you need more help, send me a message and we can work together. I'll see you in the next video. Happy learning.